Hello viewers, welcome to my channel Science to Technology. In today's show, Rocket Monday, we're going to talk about Blue Engine number 4 or BE4. So let's dive right into it. Now, before we understand Blue Engine, we have to understand Blue Origin. Now, Blue Origin was founded 8 September 2000 basically. So this is old, and Jeff Bezos now at this point in time has around 3,500 employees. So that should give you a context how big a space company has to, because SpaceX has around 9,000 plus. So you get that point. Like it's a big company, and it's a bit older than SpaceX. SpaceX is 20 years old and this puppy is 21 years old. And unfortunately, even though they are older and they have much bigger bank balance, they have not reached orbit at this point in time. They have only managed to reach suborbital. Now this is still a big achievement, because New Shepard is a suborbital tourism vehicle, meaning it's supposed to launch as quickly as possible, and they have succeeded in doing so. Because many times people will say, oh, they lost to compared to Virgin Galactic, but here's the deal: how many times it has been launched with people? One. This puppy, it's on 4th or 5th at this point in time. By the time you may watch it, it may be on 5th. So you get that point. Like, it's successful. They have built a system. Again, it took its sweet time getting here, but it is here. And many times people are very angry about the fact that these people are getting, like, merit of basically astronaut. Reality is they should get it, simply because that's exactly what it took to start the space race. Meaning what they are achieving right now as a just normal thing, it was a very big deal. Like, if you took this rocket and went into 1950s, they're like, how the heck you are doing this? That's the whole point. It's a very big deal, and as a tourism data point, it's a really good thing, because like they claimed it, they are delivering it. While Virgin Galactic is like, we're gonna deliver in 2021 and we're gonna deliver in 2021 and we are still waiting. So this delivering again and again. So it's a really good system. However, their main bread and butter is supposed to be New Glenn. Now that's an orbital system. Basically, Falcon 9, if it had a bit more money, because Falcon 9 is way too skinny. Now Elon Musk, from a business point of view, did made a very good gamble. He was like, if you make the rocket skinner, we can use just any rockets. That's awesome, cheap, efficient. He did not have boatload of money back then, and consequence, the fairings are small, and that's the only limitation Falcon 9 at this point in time has. Even Falcon Heavy, it can carry GG amounts of tonnage, but it simply cannot carry the big enough things because the fairing does not allow it. So New Glenn does have better fairing. So even if the total thrust output, total capacity to low Earth orbit is maybe the same, it will still get boatload of contracts, simply because of the large fairing. So that's supposed to be launched by now, but bit behind schedule, let's just say. So BE4, what is this puppy? This puppy was supposed to be the workhorse for New Glenn, basically how Merlin is for Falcon 9. However, work started on it in 2011. Right after that, now be mindful, Blue Origin is a very close-knit community. Basically, they do not expose anything about it, like nothing. It's like absolute secret. So randomly in 2014, ULA announces that they're gonna work with Blue Origin, and they're gonna use the BE4 engine compared to Rocketdyne engine, into their Vulcan series of rocket. Now, at that point in time, Blue Origin promised ULA that BE4 would be ready for flight by 2017. Now, if you're like, wait a minute, that sounds way ago. Yeah, it's a bit low, behind schedule. And the target oomph of this puppy is around 240 tons. Now, be mindful, that is huge. That's why it only needs 2. And the solid booster, again, it does add a bit more love to it, but you can still launch this orbital class rocket with only 2 main engines. Still have GG amount of tonnage. So it's a powerful puppy. Do not make the mistake like, it's a behind schedule. It is a big puppy. It is a big and powerful puppy, and it should have easy reusability. Every aspect of the system was designed from day one to be very efficient and reusable. And mind you, that's the whole reason New Shepard is a thing, because the whole engine system is very efficient and very clean, because it's using hydrogen, and it has surprisingly good deep throttle, meaning it can just like hover. No other rocket can hover at this point in time, simply because the throttle does not go deep enough. The only reason why basically Starship could hover is simply because it will turn off its engine. Deep throttle, like basically Blue Origin engines, yeah, that's on a whole next level. So BE4 had a lot of high expectation, because BE3 and BE2, they were like really good. So what's the design behind? Design is, this is going to be oxygen rich. Now, why the heck you want to burn things oxygen rich rather than fuel rich? Now, again, if you have light particles, basically, let's say in space shuttle, you had hydrogen, so you will overflow the hydrogen, because you do not want temperature. Be mindful, you do not want temperature. You want gas flow in your, basically this. You want gas flow. You do not want just like, I have the highest temperature there possible. You don't want high temperature. You just want as much flow as possible. So you burn the fuel to its 100%. Now here's the deal, that 100% is stoichiometric burn, it's very high temperature. Now how do you cool it? Again, depending on system, let's say in space shuttle, they overflow it with hydrogen. Here, they are deciding to overflow this puppy with oxygen. Again, oxygen is a lighter gas, so it will translate into much more oomph, much more specific impulse compared to, let's say, methane, ethane, butane. Now, in terms of fuel, that's why I specified these three things, because they are using liquefied natural gas rather than pure methane. Now LNG, the primary component of LNG is CH4, so more or less it's gonna get the same specific impulse if it was running on basically CH4. Now be mindful, it is backwards upwards forward forward compatible with CH4. Let's say for some reason they find out like their specific impulse is not as good as they wanted, they can switch this puppy to methane only if they want to, and it's gonna use liquid oxygen. So this is this whole idea behind it. The reason they are choosing to go with LNG directly rather than purifying the LNG into CH4 is A, cost, B, availability. Because you are familiar with the fact that RP1, the one that is used in Saturn V, the one that is used in basically Falcon 9, it's kerosene. Now here's the problem with that. Kerosene, that normal Tom and Dick and Harry kerosene, is this expensive. Now kerosene goes into JP1, that is jet propellant one, this expensive. Then you go to RP1, that's expensive. So that's why even if you are think, oh, this is just CH4, to get that CH4 to purified level where SpaceX will use it, it's expensive per ton wide. So they may are like, what, it does not give that much oomph where it's like it's actually justified. So from their point of view, it's like, we can work with LNG, it's good enough, the supply chain is there, everything is fine. The reason why you do not want long hydrogen carbons, simply because it creates soot, it creates a basically polymerizes, basically it can become plastic, and that was a very big issue and limiting factor of Merlin engines. Merlin engines requires extensive cleaning after every operation, and that's why you see brand new Falcon 9 is like, wow, lovely white, and it after 9 launches is like, dude, why you black? It's like, where the heck this black thing come here? Is space dusty? No, it's the engine is dusty, engine is creating soot. So that's why they are using LNG. It's good enough to methane, and cheap enough where it's like from a cost to power ratio, it's like, yeah, we can manage it. And it's going to use single shaft design. Now the reason why they are going single shaft rather than having two independent turbopumps with a two independent generator like full stage combustion system that Raptor is using, because of low complexity, meaning you're going to have one pre-burner. It was same design done by Space Shuttle. It has one pre-burner. Only difference was Space Shuttle still had two basically shaft, one shaft for hydrogen, one shaft for oxygen. The primary reason for that, density wise, hydrogen and oxygen is too far apart, meaning pump for hydrogen is to be this huge and oxygen this huge, because again, density, liquid density, you want something that like oxidizer and propellant should be more or less close to each other. Methane and basically liquid oxygen more or less close enough so they can use one shaft without requiring like ludicrously high RPM change. So they're using one shaft system. Doing it one shaft does simplify this process. Like you can see that like the engine is rather simple compared to Raptor, but does come with a consequence that it puts lot of stress on turbopump, because when we are talking about a rocket engine, you have to understand the only difference between a rocket engine and a flamethrower is turbopump. Rocket engines are just flying turbopumps, because turbopumps take energy and pressurizes that puppy, meaning you have chemical energy in your liquid oxygen and liquid whatever propellant, methane, they are trapped there. You want to liberate it. Now if you liberate it, it's just a fire. You want to get thrust out of it, you have to liberate it at fast speeds, meaning the flow rate has to be idiotically high, as in like liters, hundreds of liters, or even tons per second kind of ludicrous speed you have to do. So turbopumps require boatload of energy. They require basically miniature rockets to fire. That miniature rockets exhaust drive the turbine. That turbine pumps the pump basically. So it does put a lot of strain rather than having two independent systems where you can optimize the RPMs and like have two lower stress components. It does add one giant stress component, but it's simpler to manufacture. So LNG is already cheaper and good enough. Be mindful, LNG is a compromise compared to 99.99% CH4, but it's good enough where it's like, yeah, does not matter too much. So what's the problem? Why the heck a company that is capable of making such deep throttle rocket engine, why the heck they are struggling so much? Well, the engine complexity is too goddamn high, meaning in terms of power. This puppy is more closer to basically Falcon F1 engine that was used in Saturn V. That's why like you will only notice two engines taking like something to orbit. It is powerful, like that is gargantuan engine, really powerful. But like, it's like almost twice as powerful if done correctly. Again, they have not reached it yet, but they should. Over time they will reach it there. And combustion instability was a big issue. When you have giant engines, you have giant injection plate. Giant injection plate generally means boom, and boom is very common in the rocket industry, because when they built F1, they tested it, it went boom. They built it again, tested it, it went boom. Time and time again, it kept going boom. And somebody had an idea, why don't we just put CFO just for lols? And that's how they figured out how to stabilize that system. Basically, they had to introduce disturbance such a way that inherently over time it removes the oscillation in the fuel price. That's rocket science. That's how they've solved the basically combustion instability. So combustion instability is a big thing, especially when you are making big engines. It's a big issue, but it should be solvable. At this point in time, this company started 2015. They should have been able to solve it. Then you have turbopump. Now that's a very big issue, because this inherently is more or less control C control V of Russian designs. Now Russian designs, you will notice many of them, specifically very high power ones, they have a turbopump and they have 4 goddamn nozzles. The reason why they have 4 goddamn nozzles is just so they do not have to deal with combustion instability. That's one way of solving it. And the sole reason Americans succeeded to reaching to the moon, because they solved it on the injector plate rather than having 4 different nozzles. So that's the one thing. Turbopump is very stressed out, and that is directly causing overheating on all the components. Now this is supposed to be a reusable engine, and they really, like in the early development, they found out like this puppy will self-destruct before it even reaching the orbit. So it was just not good enough, so they had to rework a lot on it. And at this point in time, you have to understand, I'm taking all this data from one specifically amazing video. I have provided the link down below. That is like, why the heck they're having so much issue? It's most likely because turbopump is having a hard time, because you are want to pump this big boy with one shaft. Like how much oomph you can put in a turbine, because turbine has an upper limit. Like you have to put way too many stages, that will add too much weight, and you have to drive it harder, that will put wear and tear on the turbine blades itself, and the blade have a upper limit. It cannot just go YOLO on the RPM wise. It will self-destruct because of centrifugal force. So there is some serious limitation there, and that's the most likely the bottleneck. Because again, combustion instability is an issue, but we have solved it. Like as a established rocket engineering industry, we have sorted it. It's one of those things that we got this. And overheating, again, it's one of those things that we got it. But what is the missing link? That is the the biggest issue. Turbopump. That's one thing that we have no backup for. So okay, they have hired people, why the heck they are having such a issue? Now this is the biggest sad part about this, is poor management. Flat out poor management in the early years of development led to insufficient hardware. Now why is that the issue? Well, that's the job of manager. Basically, if your engineer department says, hey, we need 10 injector plates, you're like, oh, you need 10, hey, order 20. You know for a fact, they're gonna build it and it's gonna explode and they're gonna need more. That's how it's done. Like, to give you a context of that, RS-25, basically space shuttle engine, just to figure out how to start this engine, they had to explode the engines. Basically, okay, oxygen flow is too high, okay, hydrogen flow is too high, okay, we have to stabilize it, stabilize it, bogo it up basically, so it smoothly starts up. That's how it's done. Like literally, there was no other way of doing it. It's like just brute force test it. It's like, yeah, it exploded, okay, build another one. That's the whole job of a manager. It's like, we know for a fact that you think it works, the real world will bitch slap you, so we have something in buffer. Now SpaceX knows this. That's why, like, look at Starbase. You are seeing many rockets built, full size rockets, and they're just like, yep, tweet. Why the heck they are doing that? Because they know for a fact that all they are doing is learning. So this was a very big management failure, where they had insufficient hardware. That directly led to slowdown in troubleshooting. Basically, oh, this is not working, yeah, I have to wait 3 months for new parts to come in. That slows down troubleshooting and iterative development, meaning they cannot be like, let me tweak this, let me tweak something else. Oh, it did not work, how about we test this? Like, this directly translates to a behind schedule engine. Like, if you have a bank balance of Jeff Bezos, this should not have happened. The only reason, again, bit of delay, that is expected. Like, they may thought, that turbopump would be easy, and they're like, turbopump's like, nah man, I'm not easy. So in those sorts of things, again, some delay is expected from 2017 to 2018 to 2019, not 4 years and still behind schedule. That should not happen. That's only happened because of poor management. They were very hardware poor for a very long amount of time. Now at this moment in time, when I'm making this video, they have claimed that they have sorted it out, and the first 2 functional engines are going to ULA, and ULA will be launching them into orbit, hopefully. So what we can expect in the future at this point in time? Now you have to understand, ULA is under serious pressure. I mean, defense industry kind of pressure. They cannot lull to it. Basically, they have to deliver it. There is no other way. Otherwise, they will get into some serious legal, idiotically expensive troubles, which they do not want to afford. So, and not to mention, SpaceX is already putting pressure as in, like, taking away their contracts. They have to deliver this puppy. It's not optional, and even this delay will be investigated. So they have to. They are like under serious stress. Now Jeff Bezos also wants to do what Starlink is doing using Kepler system, Leo constellation they want to build. Again, that cannot be done if it has to, buy rockets or somewhere else. So Jeff Bezos is risking a lot by basically ordering a lot of Vulcans. Now, the reason for that is like, I will get the ball rolling. By that time, I will, develop my New Glenn. Once New Glenn is done, like I'll take care of it. The sole reason SpaceX can even launch something like Starlink and does not go bankrupt instantaneously is simply because they have in-home rockets. And basically Blue Origin have to do that, otherwise Kepler is dead before its arrival. So it has to be done. Right now New Glenn is just CG. There's just CG, and that's another aspect of it. Like, whole New Glenn should have been ready. Whole New Glenn. Again, like, think of this: Raptor is still going under production, but how about the chassis? How about the heat shields? How about everything else that has been sorted? Simply because they are, hardware rich, SpaceX wise. They are not hardware rich. They are not building this. Like, only one markup was made. It's like, what the hell? Are you serious? Even are you actually serious about making something that actually goes to space? Because that's not how you do it. You have to, like, iterate everything. The fairing should have been built, the chambers have been built, pressure testing should have been done, hundreds of things that can be done should have been done. They did not do it, and they do not have money issues. So right now New Glenn is just CG, and NASA in USA needs this. This is one of the things that I've noticed many times in basically comments, is that people are like, SpaceX should do everything. That's not good, because be mindful, right now everybody is like booing basically Boeing. Now here's the deal. Boeing is the granddaddy that built the goddamn Saturn V. Now again, not whole Saturn V. IBM also played a role, and other companies also played a role. But Boeing was a critical part of it. Meaning, if you take Boeing and twink it out of Saturn V is not going anywhere. And they did it. They delivered on time. That's why, like, Boeing is such a big name in aerospace industry. It is earned name. Now SpaceX is earning that name right now, but you have no guarantee that, let's say, after death of Elon Musk, that company will remain the same way. Company may just go, there is no actual competition, so we might just increase our prices because lol. You can't do anything about it. Under no circumstances NASA wants to be in a position where there's like, SpaceX, can you do this? How long will it before you can do this? Because again, they do not have any option. NASA does not want that, and USA also does not want that, because if you have multiple companies, let's say ULA starting to get their act together, Blue Origin starting to get this puppy together, that puts pressure on everybody. That also puts pressure on Rocket Lab. It's like Rocket Lab, I'm saying, yeah, Rocket Labs, where it's like, we'll make sure that Neutron is delivered on time, on schedule, and all budgets and all that. That's why you have competition. That means if something happens, let's say Russia goes, I'm gonna block all your engines, USA will be like, I don't care. So that's why you want more competition equal more better. Like, there is no two way around it. You, under no circumstance, any Tom, Dick and Harry is like, we should cancel this project and all that. Again, I do want basically other projects to be cancelled, but cancelled in such a way that please deliver, and now you pay the bill. You have delayed it because, again, NASA does have the authority where they can open an investigation, which will be very expensive. If NASA actually goes like, I'm after your ass is destroyed. So NASA should pull that one. Specifically, I'm pretty sure ULA is already feeling the pressure from, and because this defense industry has a bit more money. At that point, if defense industry comes to you, it's like, sir, why your rocket is late? That's not something fun. Let's just put it that way. So we want more competition. So this was my presentation on BE4. Hopefully you have liked it, learned from it. In that case, please click the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show me extra disappointment. Please leave a comment, because I do try to reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.